Hello, my name is Ashish Sangave. I am a graduate student at Clemson University, and for my design innovation video, I am going to talk about the drones, which are also referred to as unmanned aerial vehicles. The term drone was coined in the early 90s in reference to the target aircrafts used in practice firing for training military personnel, and the term was first used in 1920s Fairy Queen target aircraft. The drone development continued during World War I when the Dayton Wright Aeroplane Company invented a pilotless aerial torpedo that would explode at a preset time. The earliest attempt at a powered UAV was A.M. Lowe's aerial target in 1916. With the advent of new technologies ranging from GPS to faster and smaller computer processors, there has been a surge in development of unmanned vehicles. The drone designs started getting more compact and serving a variety of applications apart from military. First, I will explain you about a typical drone design system. As shown in the block diagram, the user controller sends a signal to the wireless transmitter, which transmits the signal to the wireless receiver. The data is then passed on to the flight controller, which in turn controls all the motors, sensors, and gyroscope. There are also some crucial mechanical components in a drone. The propellers. They play a key role in providing fully attached flow to the drone and maintain the drag to thrust ratio in the ideal range. For motors, the principal concern in selection is power output versus motor weight, as any weight added would require power expenditure to keep it aloft. For batteries, in addition to the weight benefits, the batteries should be homogeneous in performance, providing consistent and reliable performance at lower cost. Some drones also use gearing to provide desired reduction ratio. Now it's intriguing how the drone flies in different directions and at different speeds. What's the design mechanism behind it? So basically, in order to pitch or roll the drone, one propeller would speed up while its opposite partner in rotation direction would slow down. The result would be a roll or pitch moment caused by the difference in thrust produced between the two propellers. However, since both propellers are changing speeds and share a rotation direction, the reduction in drag on one propeller is countered by the increase in drag on the other propeller, resulting in no net torque about the yaw axis of the drone. When the drone needs to yaw, a pair of similarly rotating propellers are sped up, while the pair of propellers rotating in the opposite direction are slowed down. Since similarly rotating propellers are located across from one another, speeding up or slowing down both produces no roll or pitch body movement. Since two have sped up while two have sped down, the net thrust also remains constant, thus no change in vertical acceleration. The last controlled vehicle degree of freedom is the vertical throttle. It is the simplest of the four and is controlled merely by speeding up or slowing down all four propellers equally. Now there are numerous reasons why I feel this design is innovative. Firstly, it's compact due to the use of smaller and efficient controllers. Such designs also require less power for its motion over large distances. In comparison with their so-called counterparts, the helicopters, the drones provide better control in turning. One of the major reasons why I feel this product is innovative is because it does not require a pilot, which saves a lot of manpower and also limits military losses for army applications. The benefits of unmanned vehicles also include the degree of maneuverability and flexibility in deployment that has historically been unachievable when accommodation for a human pilot were necessary. Another big plus about the drones is that it saves massive amount of money required for cranes and huge setups for photography and site inspection purposes. Moreover, it can be accurately guided over large distances. It also has the ability of easily reaching intricate places and doing tasks which are hard to be done by a human. The implementation of some methods in the design played a vital role in creation of this innovative system. Firstly, the gyroscopic effect. Gyrostabilization technology is one of the components which gives the drone its smooth flight capabilities. Then there is GPS, which provides accurate navigation and tracking the drone. And lastly, the drones use obstacle detection sensors to scan the surroundings and react accordingly to avoid collision. With such advanced technologies, the drones have numerous applications. Some of the major sectors include site inspection, photography, search and rescue operations, agriculture, aerial and underwater surveillance, border patrolling, and finally, better intelligence gathering to strike high-value military targets with low civilian casualties. Unmanned and autonomous drones are currently in development for use in air, over land, and in water by both private and government agencies, and is likely to be developed for more applications in the future. Here are some of the references that helped me gain all the information I needed to make this video. Thank you.